So today I just want to make a response to Black Pen Red Pen's video where he took the derivative of ax squared plus bx plus c, a quadratic. So what he did was took the derivative of the quadratic formula. Now looking at it, I want to think of something original. So I'm deciding to take the integral of ax squared plus bx plus c with respect to a, of course. Okay? Now, if we just take it normally, we'll get x squared, a squared over 2 plus c. But that's not very good. Okay? But we know x is equal to the quadratic formula, which is negative b. In this case, plus or minus, but I'm just going to go with plus, since I want to make my life easier. The square root of b squared minus 4ac over 2. Okay? Or 2a. So this is the function we're going to be integrating. Okay, with respect to a. So now what we're going to do is just make our integral. We'll have negative b plus the square root of b squared minus 4ac divided by 2a dA. Okay. Now let's look at this function. We're integrating with respect to a, so everything else would be a constant in this case. So I think the first part I want to do is maybe get rid of this constant 1/2, because it's just making us, because if we can get rid of it, we can maybe do a u substitution here. Okay, so let's just get rid of it. So we get 1/2 the integral from negative b plus the square root of b squared minus 4ac over 2a dA. Or no, over a, my bad. There's no 2 because we got rid of the 1/2. Okay, now let's do a u substitution. I feel like this would be a good spot for a u substitution. Okay, so we have our u, which is equal to, let's set u to our radical here, which will be square root of b squared minus 4ac, and then du, we take the derivative of this. So we'll get 2c divided by 2 square root of b squared minus 4a. Okay. Of course, dA. Almost forgot that. Now we're just going to plug the u and du into our equations, or into our integral here, and that'll give us a result. So if we just move it up here, the integral of u over u plus b du. Okay. Okay. Now this function is a lot easier to differentiate or integrate than this mess. So now what we're going to do is want to separate it. We can do another u substitution here, but we can use a little bit of algebra just to make it simpler. So we can write this as, we can write u over u plus b as the integral of u over u plus b times, u plus b or minus u over u plus b, okay, du. Okay. Now, actually, no, this is b. My bad. We simplify that out. We'll get the integral of 1 minus b over u plus b du. Okay. Now we just integrate this normally. Okay. Just take the difference rule. It'll give us, so the integral of 1 du is just u minus b over u plus b. We can use a u substitution here. We can substitute u plus b for u, and then we'll have b ln of u plus b du, or no, plus c. All right. Now we're almost done here. We just need to plug back the u, our substitute values. So if we just expand it out, we'll get our radical, which is b squared minus 4ac, minus b ln. I'll just put the absolute value signs just to expand our range a little bit. And then we'll have the square root of b squared minus 4ac plus b. And of course, plus c to indicate it's an antiderivative. So there you go. That is the integral. Well, actually, you're not done. You may think we're done, but we still remember we have to plug in this solution into here just to make it all together. So we're going to plug in our x. So this is x. So we'll get square root of b squared minus 4ac minus b ln of square root of b squared minus 4ac plus b. Okay, there we go. And then I'm just going to, I don't feel like simplifying it, so I'm just going to make it squared. Easier. And then times a squared, all that divided by 2 plus c. And there we go. That is our final integral for ax squared plus bx plus c. Okay? So, which one do you think is more satisfying and easier? Black pen, red pens, taking the derivative, or me taking the integral of it? Okay? So, that's about it. Have a great day.